Alaikum assalam wa rahmatullah.
How are you doing?
Fine, alhamdulillah. Teacher,
Yes, yes.
many students ask about the recorded.
Regarding actually, there's only one way. I checked it. So before even finishing the class, I will send you the link on YouTube. So I will upload on the YouTube, and then you can check from there. There's
Yes,
only one way for others, for the students who are from different sections, not from my section, means from this section. So they can have the recording on YouTube. Hopefully, I will upload it on my channel, and then you can watch it there. Hopefully, because I'm trying my best, or because it's impossible for other students from other section to come here and then to directly open the link. If you're from the same section, you can open the link.
okay. Thank you very much.
So
Thank you.
during the class, I will upload on the YouTube, and then if I am successful, I will send you the link, or even my channel, because I have YouTube. You know, all of us, we have YouTube because Google account is connected to YouTube as well. So I'll upload it there. Okay, let's start our topic today. I think we have, let me share with you. Okay, can you see my screen?
Yes, yes.
Okay, so today we're going to study, I think, concentration of solution. Concentration of solutions. Before starting concentration of solution, we should know about solution first. What is solution? Solution, actually, we have two parts of solution. One is called solute, and the other part is called solvent. And then if you add them together, like solute plus solvent, it will make a solution. So which part is called solute usually? Solute, the part which is
It's
being in the solution
dissolved.
in, it's the, you can say less quantity, less amount or less quantity. And what about the solvent? The solvent which is the most quantity. The most quantity. This is the definition of solvent and solute. So we can give a lot of examples. Suppose in air is a solution in which we have gases. We have three main gases in air. We have carbon dioxide, oxygen, and nitrogen. Three main gases are there. So which one is solvent, which one is solute? It depends upon their quantity or the share. So we say that oxygen is almost 21%, nitrogen is 78%, and carbon dioxide is 0.3%. And 0.7% are some other gases like methane gas, like noble gas, like neon, argon, etc. So which one is the solvent here? You check the most quantity, which is nitrogen here, we call it this is a solvent. So for air, nitrogen gas is a solvent. Why? Because it is found in larger quantities, 78%. Oxygen, carbon dioxide, other gases, they are solutes. Now if we go to the liquid solution, we call it aqueous solution. Aqueous solution. Aqueous solution, if one of the component, usually the solvent, if solute, if the solvent, usually we say, if the solvent of your solution is water, we call it as aqueous solution, AQ. We write AQ in the bracket, or we write AQ like this, aqueous solution. So today we are not talking about any solution, rather we will talk about the aqueous solution, because the most common solution in our practical life is aqueous solution. Aqueous solution, suppose we have sugar plus water, so they'll make a sugar solution. So we'll say sugar, and then here we write AQ, aqueous solution. So water is solvent, sugar is solute, so we have aqueous solution. If suppose we have salt plus sugar plus water, again it is a solution in which water is solvent. Usually the solvent should be 1, and the other component which are less quantity, we call them solute. Solute maybe 1, 2, 3, 4, 5, whatever it is. So but the solvent should be only 1. So these are solutes. Now the next question is, which is important as we call it, how much solute is present, is found, you can say found in your solution. You want to know, suppose the sugar is in your water, you want to know how much sugar is present in your water. You may add less sugar, you may add more sugar. So this is why we call it, this is called concentration. We call it concentration. What is concentration? The amount of solute you dissolve in certain quantity of solution is called concentration. Concentration is the amount of solute, or you can say here, if I can define it here, the amount of solute dissolved in certain quantity of solvent or certain quantity of solution. It is called concentration. We call concentration. Concentration. Okay. Now next slide. Let's go for the next slide. Suppose now we are talking about sugar solution. I am making sugar solution in water, aqueous solution. I am adding sugar plus water. Suppose we have 2 cups. This is cup number 1, this is cup number 2. The cup, you know, the capacity is same. Suppose we have 150 ml or 120 ml capacity of this cup, 120 ml this one. And there is a tea here. We want to make tea basically. This is tea. We take 120 ml of tea here and here, and then we add 10 gram of sugar, or you can say we add 1 spoon of sugar, teaspoon. and here we added 2 spoons of sugar. Which solution or which teacup will be more sweeter? This is cup number 1, the second one. Of course, the second one. Why? Because the solution quantity, the overall quantity is same, but here we added 1 spoon, and here we added 2 spoons. So, but in reality, or in chemistry, or even in the practical world, we do not use 1 spoon or 2 spoons. 2 spoon, 1 spoon is good for normal way. But whenever we talk about the exact quantity, spoon is not a measurement. We cannot measure with spoons. Rather, in chemistry, in all other subjects, or even our sciences, we use masses. We use masses. So we should know how much 1 spoon, what is the mass of 1 spoon? If I say the mass of 1 spoon is 10 grams, and the mass of 2 spoons, definitely it will be 20 grams. Now, or if I want to write it in a scientific way, so for this one, we will say 10 grams and 120 milliliter. Of course, 10 grams of sugar we dissolve in 120 ml of solution. In the second one, we say 20 grams and 120 ml solution. That's very nice. It makes sense for us now because we know exactly the mass and the volume, mass and volume. So this is called a concentration unit. But the problem is we don't use like this. We have certain units. We have certain units for concentration. To express the concentration, we have units. The first unit is we call percentage. We call it percentage. Percentage means you multiply by 100. And the most common thing, we have W by W. W actually, we call it weight. One thing I want to tell you here, that in chemistry, the weight is always equal to mass. That's why sometimes you will find molecular weight. And at the same time, you may find molecular mass. Because mass and weight, they are interchangeable in chemistry, mean they carry the same meanings. But in physics, they are different. Weight is completely different from mass. Weight is a kind of force. The unit is Newton, and mass is a mass. It is gram or kilogram. Okay, but in chemistry, they are same. Weight means mass. Mass means weight. So that's why here weight start from W. We call weight divided by weight in percent weight by weight. This is the most common thing in chemistry, especially in your course. So these are the units. So let's talk about W by W. How we'll find W by W? Okay, let's go for the next slide. The same example, the same cup, okay, 10 gram in 120 ml, and this is 20 gram in 120 ml. But here, when we find W by W, percent W by W, W means weight divided by weight. Here we don't have a weight, we have mass. Sorry, we have volume. So volume will not take it in W by W, which is in your course. So rather we will take the mass of it. Usually if it is a very dilute solution, so the mass up will be equal to the ml of water, because we know that the density of water is 1. So mass is equal to, we don't know if the volume is 120 milliliter. So mass will be equal to density multiplied by volume is equal to 1 multiplied by 120. So it will be equal to 120 grams. If it is a dilute solution means you add a little bit of sugar into the water. But however, it's not a big deal. Rather to take the volume, we go to the mass here. Suppose this is the balance. We have a top loading balance, or even we have analytical balance. This one, you know this balance. Okay, here is the pan here. Okay, this is the balance, suppose. Oh, sorry. So there's the balance. You have a pan here. You just take your empty cup, and then add the solution. How much is this? You will take the mass. Suppose the mass is not 20 ml, rather the mass of sugar is 10 gram, but the mass of solution when you take it is 122 gram. Okay, what is the percent WW of in this solution? In solution number 1, we take 10 gram of sugar, and then the mass of solution, the volume is 120 ml, but the mass is 122 gram. Whenever it's been asked from you, you will be given mass, not volume. If the volume is given, you will be given density then to take the mass. Okay, so usually you will be given mass. So 122 gram, and then you will say for percentage, because you find the percentage, you multiply by 100. Now, if you have a calculator, you can solve it. I don't have a calculator. Can you solve it?
8.33.
8.33%. Okay. Now go for the second one. It will be 20 divided by 1. Suppose it is 125. Suppose even 122, you can say the same thing. Okay, forget about this one. So how much you multiply by 100? How much?
16.66.
Okay, 6, 4 or 6. So look at this. Now from even the percentage, you know how much sugar is there. In this solution, my sugar is, the percentage of my sugar is 8.33%. That's why it is less sweeter. In the second one, my sugar is how much? 16.6. So it is very useful. From the percentage, you know how much solute is present. No need to think about it. Okay. Now I will give you a little bit different example from the same percentage. Okay. Suppose we have 10 gram. We dissolve in 180 gram of water. This is number 1. Okay. Number 2, we have 5 gram dissolved in 70 gram of water. Which one will have more concentration, sugar concentration? Which one will have less sugar concentration? You find by percentage. Okay, let's find by percentage. For percentage, we have this formula: W by W is equal to mass of solute, which is sugar. You write solute divided by
the second one, teacher.
Mass of solution. Now this is a common mistake that usually the student do. It is water solvent. This is water solvent. Whenever it is being dissolved in not only in water, it means solution should be the mass of, because solution means we already added solute. So solution means solute plus solvent. The mass of solute plus mass of solvent. So in the first case, we have 10 gram. Solute is 10 gram. We will write it here. Divided by, you will multiply by 100. Divided by 10 plus how much in the first one? Where is 180? And then you will close it. Is it clear now? If it is written water, if it is written solution, no need. If it is written water, means it is a solvent actually. It is a solvent. So solution means solute plus solvent. Okay. So, and then in the second case, we have how much? Percent W by W. Mass of solute here, it is 5 gram. And mass of solution is 5 plus 78 means 75 gram. Multiply by 100. So what is the concentration? In the here and here. Here it means you will write 190 in place of 180.
6.66.
The first one 6.6%.
No,
and
no,
the second
no,
one is
the second one.
The first one is 5.3.
5.3, huh? Okay. And the second one is how much?
6
6.6.
point
6 point.
0.6, teacher.
Okay, good.
Almost
So which one
0.6.
is more sweet? Okay, forget about this one. Means 6.6 or 5.3. Which one
The
is more
second.
sweeter? Here we added more sugar. Here we added less sugar, but this solution is more sweeter. Why? Because the total quantity of solution is less. So it means this will give you an idea that the quantity of solute itself does not matter. The quantity of solute does not matter. The quantity of solute matter with the quantity of solution as well. So here you added more, you think it should be more sweeter, but it is not. This one is more sweeter. Why? Because you added here, the amount of water is less. So your solution will be more sweeter. And then how do you know this? Just go for the percentage. When you find the percentage, it's crystal clear which one is more sweeter, which one is less sweeter. The one which is more percentage, it will have more sweetness. Clear?
Yes.
Any question in percentage?
Teacher,
Yes.
it can be the two element solvent and solute have the same weight.
Yes, of course, it can be. Doesn't matter. Same weight means how? Means solute, solvent, and
For example,
is
I
equal
have
to solution.
10 milli.
Like this?
Yes,
Okay, yes.
10 milli and 10 milli.
Yes, it is possible. It is possible. Okay.
How
But
can I identify the solute?
suppose you
and
have
the
10
solute?
milliliters, so 10 ml of water, the mass is 10 gram. Okay. Now you want to dissolve 10 gram of sugar. 10 gram of sugar in it. Okay. So means what is the total mass of solution? 10 gram of water and 10 gram of sugar. The total mass will be 20 gram. And then how much
Yes.
sugar you have here? 10 gram and multiply by 100. So it will be 50%.
Yes.
Yes. Thank you, teacher.
Okay. So now we go for the other concentration unit. We call it just like percentage. We have ppm and ppb. ppm means parts per millions. Okay. And ppb is equal to parts per billions. Parts per billion, parts per million. This is same like percentage. In percentage, we have parts per 100, is it? That's why we multiply by 100. We have the percentages like this. Mass of solute divided by mass of solution multiplied by 100. This is percentage W by W. Multiply by 100. But in ppm, we will say same thing, mass of solute and mass of solution multiply by, because it's parts per million, million means 10 to the power 6. That's it. This is the difference. Here we multiply by 100, and ppm we multiply by 1 million, which is 10 to the power 6. And then ppb is the same, but only here you will multiply by 10 to the power 9, which is a billion. But the question is, if we have a percentage, why do we need million and billion, ppb and ppm? Okay, I will give you the example.
More accurate.
No, let's go for this one. Why we use ppm and ppb? Suppose if I say the chloride, if you have a water bottle, you can see. If you have water bottle with you, the smaller one, maybe 330 ml or 500 ml, 600 ml. The chloride content, we have the mineral water, we call mineral water. The chloride contents in water is 0.0005 grams in 1000 gram. 1 liter, usually we say 1 liter equal to 1000 gram, because water density is 1, so 1 liter will be equal to 1000 gram or 1 kilogram. So what is the concentration? The concentration of chloride. Chloride means Cl negative. Okay, this chloride, this is Cl negative. Now if I can say 0.005, if I multiply with 1000 to make it milligram, usually you know gram milligram, 1 gram is equal to 1000 milligram. If I say this is not this one, you will say 0.5 milligram. Okay, suppose if I say like this, usually in these kind of equations you must have the same unit. You must have the same unit. Suppose now the ppm is like this. What is the amount of chloride we have? 0.5 milligram. How much is this water here? 1000 gram. Now I'm in trouble because here is milligram, here is gram. I cannot cancel them out unless they have the same unit. Because it is million, I will write like this. If I write the percentage, it will be like this. 0.5 divided by 1000 multiplied by 100. But here we should have the same unit. Here it is gram, here it is gram. So this one, it is milligram, we should change into gram. So I can write each milligram, when you change into gram, you will divide by 1000. Or if I can say like this. When you divide by 1000, I can write like this. 10 to the power minus 3 means divided by 1000. And then 1000, it's okay. Now it is gram, it is also gram. And then here you will multiply with 100. Here, the same, 0.5 multiplied by 10 to the power minus 3 and divided by 1000. Sorry, multiplied by 10 to the power 6. If you can solve this question for me, I don't have calculator.
The one with the milli, it answer is 5 times 10.
5 point? The
Yes,
upper one, the
5
upper one.
times 10 to the power
ppm.
minus 5. The upper one with the million,
Yeah, million.
it would be 0.5. Oh, sorry,
0.
1 minute. Yes, 0.5.
0.5 ppm. Good. Here,
And the other one times 100, it would be 5 times 10 to the power minus 5.
minus
5.
4 or
Yes,
5?
to the power minus 5.
Yeah, 5.
5.
Yeah, 5. Look at this. This look awkward, is it? 5 into 10 to the power minus 5. It look awkward for me. This percent. So it means it's really difficult to understand it. 5 times 10 to the power minus 5%. What does it mean? So that's why I mean. Yeah, I know. It will be like this, 0.00005, like this percent. Look how much smaller percentage is there. It's really difficult to understand. So that's why. But what about 0.5 ppm? It's easy, means good, because it look some number, huh? 0.5 ppm. Now the question is, this is good for me. If I am going for the ppb, so I will do the same thing here, 0.5 into 10 to the power minus 3 divided by 1000 multiplied by 10 to the power 9. It will be now equal to 500 ppb. Is it?
Yes, teacher.
So means we want to know what is the difference between the percentage ppm and ppb. There is no difference. The answer is correct for all of them, but the understanding level is different, because if it is something is very small in quantity, so we cannot use the percentage. We cannot use the percentage here, because the percentage, it give you a very smaller value that's difficult to understand. So we use the ppm or ppb. ppm is good in this case, but ppb is much better because 500. That's ppb. If suppose you add one, if I say you add 1 grain, the crystal of sugar in glass of water, 1 grain, or you can say 1 crystal, and then you dissolve it, you want to taste, what will be the taste? The taste will not be changed. Why?
Because unsalable.
Means no. Sugar, we talk about sugar. Sugar is soluble. You have one crystal. Sugar is usually in crystal, in powder form and crystal form. Okay, sugar has crystals like salt. Okay, we add 1 crystal, 1 small crystal of sugar in 1 glass of water,
Too small.
and then you dissolve it. Can I taste sugar in it?
No, teacher, too much.
No.
Yeah, that's why. Means if I take 1 crystal of sugar and then I go to the balance, it will give me 0.2 milligram, suppose. And then my glass of water is almost 250 gram. Okay, so what should be the ppm here now? 0.2 divided by my glass of water. I change, means either I should check the water after solution, or if I don't want to wait after solution, before solution it was 250.
Would
Now
be
after
0.2.
solution, look at this, 0.2 milligram. This is milligram. Okay, so this is gram. So first of all, I should change into grams here, because I cannot cancel milligram with gram. So I will say 0.2 into 10 to the power minus 3. Or I will say 0.0002. Okay, I say not 2 milligram. I will say 1 milligram. Make it easy for ourselves. Okay, cross it. 1 milligram, which is equal to 0.001 gram, is it? And then divided by 250 gram of water, but solution will be 250.001 gram. Don't forget it, this one.
Yeah.
Because this is 1 milligram was sugar, and the water was how much? 250 gram. So the total mass of solution will be means there will be no change, but there's still a change in it. The mass will be increased 0.001 gram and multiply by 10 to the power 6 if you want a ppm.
It would be 0.399.
How much is this though now?
Yes, 0.39 repeated.
Okay, 0.4 we will say, 0.4 ppm.
If we didn't add 0.01 to the solution, it would be 0.4.
Yeah. Okay, means whatever it is. So this means very simple. Now the question is, if you look at the water, mineral water, you have chloride, you will say it is 15 ppm. You have nitrate, you have suppose 10 ppm. All of them, they are in ppm. You say, teacher, we have chloride, we have sodium, it means there is a salt inside, but we cannot taste it because the ppm is so much smaller unit that 15 ppm, 20 ppm, 30 ppm, 50 ppm, you cannot even taste it. You cannot even, there is no impact of these ppm in the taste of the something. Okay, but if it is suppose 2000 ppm, this is a huge quantity now. You will taste it definitely. That's why the water quality depends upon these ions. Because these are called mineral ions or minerals, we need them in our food, like chloride, nitrate, sodium, we need it. We need in our water. If they are not, we cannot drink distilled water without any ions. So this is how to find the ppm and ppb. We're not going into the details of this one, that's end price. But one more thing, we finished percentage, ppm and ppb. Now we are going for one more unit we call, which is the most famous in chemistry, especially stoichiometry, we call molarity. We call molarity. Now, what is molarity? How to find molarity? Molarity, we say this, moles of solute you dissolve in. Now, there is no mass here. We say liters of solution. Liters of solution. What is liter? Liter is a volume, basically. Normally, we write moles of solute, we write N. N means number of moles of solute divided by volume in liters. Clear or not? Molarity, moles of solute divided by volume of solution in liters. This is for aqueous solution, okay, in which the water is there. Now, how to find moles? If you have the pre-knowledge of moles, mass divided by, if you know, M mass means molar mass. Suppose if you sodium chloride and then you have 58.85 gram, how many moles are there? Mass in grams divided by molar mass. So it will be mass in gram, we have 58.5 gram. And the molar mass we can find from the periodic table, which is sodium chloride, NaCl. So Na is 23 plus Cl is 35.5. So it will be equal to 58.5 again, gram per mole. But we're here, we will write 58.5 gram per mole. So it will be equal to 1 mole. It will be equal to 1 mole. But if you take, suppose we have sugar, which is the molar mass is 342 for sugar. Why? Because we have C12, H22, O11. So 12 multiplied by 12. We want to find the molar mass, plus we have 22 hydrogen, so 1 multiplied by 22, because hydrogen atomic mass is 1, plus, and then 11 oxygen, 11 multiplied by each oxygen is 16. So if you add them together, you will get 342 gram per mole. Now, if you take, suppose, 3.42 gram of sugar, what is the moles? Mass 3.42 divided by the molar mass, which is 342. So it will be equal to 0.01, I think, moles. Okay. So how will we use this formula? Now let's next go to the next slide. We will go and then we will explain it. Again, molarity is equal to N divided by volume in liters. Good. But N, what is N? We studied here. N is equal to mass divided by molar mass. M mass or molar mass. Okay, so we will substitute the N value here. So what I can do, I will write N multiplied by 1 divided by volume in liter. Can I write like this or not? Why? Because I want to put the N value. That's why I want to a bit separate it. So it will be the same thing. N into 1 divided by volume in liter, or N divided by volume in liter. Clear or not?
Clear. If you
okay, means yeah, N times 1 by liter. If I want to mix it again, it will become like this. But why I need is because I want to put the N value here. So N should be, that's why I separate N from here. However, the result will be same. So now what can I do? I will erase this one. Let's put the value of n here from here. Okay, let's do it. So n is equal to mass divided by molar mass. We talk about the solute. Okay, mass of solute divided by the molar mass of solute. Now multiply by 1 divided by volume in liters. That's it. This is the formula for molarity.
Teacher, what is N?
N, moles.
Mole? Mole. No.
N means moles.
Okay.
In chemistry, moles we denote by n, small n.
Symbol.
This is moles. Okay.
Okay.
So moles, mass divided by molar mass into 1 divided by volume in liter. But normally, what we do, we say that we have to now. There is a question. There is a question here. Number 1. 10 gram of sugar dissolved in water to make 250 ml of solution. Find the molarity. Molarity of sugar. Molarity usually we find for the concentration, we find from the solute always. How much solute is in our solution? Okay. Find the molarity of this solution. Now we have to use the same formula. Molarity is equal to mass divided by molar mass multiplied by 1 divided by volume in liter. Mass is how much? Mass of solute 10 gram. Molar mass of solute, I think we already calculated for sugar, which was 342.
180. Sugar?
Not sugar, 342. 180 is for this glucose.
Okay.
180 is for, this is glucose. This is 180. For sugar, it is like this. It's 342, I think. Okay. So we have 342, and then 1 divided by volume in liters. Now, but here the volume is milliliters, not in liters. You should be careful here. Okay. So I cannot write 350, 250. This is milliliter. If I change into liter, I will divide by 1000. If I divide by 1000, I will multiply by 10 to the power minus 3. Is that okay? Yeah. So means this is milliliter to change into liters, because 250 milliliter is equal to how many liters? You divide by 1000. This is liters. Okay. So R, I will say I will divide by 1000 here to make it liters. If my volume is in milliliter, I will do like this. But usually we make it easy for ourselves in the formula to look at this here. We go back to the same formula, and then we write 1000 here. But here, because now we wrote 1000, because this 1000 will go up. Is it? This 1000, it will go up. So it will make like this.
But
and then it will
milliliter in the
yeah. But here it will be milliliter now. If you write 1000 up here, now it is in milliliter.
Yes.
You cannot write in liter. That's why it means you show the formula mass divided by molar mass into 1000 divided by volume in milliliter. The formula comes from this one. Okay, let's go for this equation again in the next slide. So molarity is equal to mass was 10 gram and molar mass was 342, and then we have 1000 here, and then what was the milliliter? 250. Can you give me the answer for this one?
Zero point 0.11.
0.11, huh?
Yes.
Moles per liter.
Yes.
Or even you can say molar, M, capital M. So this is the molarity. Now we have another thing. Suppose we say that 1.5 gram of sodium chloride was dissolved in 150 ml of solution. I didn't say water. Okay, I will say solution. What is the molarity of sodium chloride? 1.58 grams, suppose, 1.5 gram. So I will use the molarity formula. Molarity formula is N divided by volume in liters. But I changed it here. I don't write like this. I will write the other formula, which we solved it. Mass divided by molar mass multiplied by 1000 divided by volume in milliliters. So that's okay, good.
Yes. Milliliter.
So here, what is the mass here? 1.5 gram. Mass should always be in gram. If it is in milligram or kilogram, you must change into grams. If it is in milligram or kilogram, you change into gram. Mass should be in grams. In percentage, it was not mentioned. You can put in grams or milligram, but they should be same units. Suppose in percentage, if you remember, if it is milligram, here is gram, so you should change this into grams. Or you should change this into milligrams. If you don't want to change this to grams, change this to milligrams. So it should be same units. But here, it must be in grams. No milligram, no kilograms. If it is in a kilogram, change into gram. If it is in milligram, change into grams again. Okay, what is the molar mass here? Sodium chloride, we should, I think, solve it. 58.5 multiplied by 1000 divided by 150. So you will have answer, you can answer it.
.17.
0.7 mole per liter. Or
0.17.
0.17.
Okay.
0.17 mole per liter, or 0.17 molar, capital M. Both are okay. This also.
So teacher,
Clear? Yes, please.
the molarity, to find it, I divide the number of moles over volume in liter, right?
Yes. This is the main formula. Because this formula, it is useful. We will use it in another place. Look at this. M N divided by volume in liters. Sometime, if we know the moles and the molarity, we can find the volume here. This is a very useful formula. We will not forget it. However, we use this formula calculation. But this formula is also useful. If you have the volume in moles, you can find the molarity. But if you have the molarity in volume, you can find the moles. If you find the mole, you can find the mass. Okay? So let's go for further. This formula, don't forget it. But we will use this formula for calculation. If the mass is given and then the volume is given, find the molarity. For molarity calculation, we will use this formula. Okay? Now, next question. A solution, now it's a bit difficult, has a molarity of 0.1 molar. Good. Molarity is given to you. And volume is 150 ml. Good. Now, what is the mass of, suppose sodium hydroxide taken in this solution. I make it complicated. So we say a solution, we have a solution. The molarity is how much? 0.1 molar. And what is our, the material? NaOH, sodium hydroxide. This is the common one we use. Now, how much volume we have?
150.
What do I need? Mass of sodium hydroxide, huh?
Yes, multiply 0.1 and
Look at this. We have this formula. First of all, you use the same formula. Molarity is equal to mass of sodium hydroxide, because we're talking about sodium hydroxide here, NaOH, divided by molar mass, the same sodium hydroxide, multiplied by 1000, divided by volume in liters, milliliters. So molarity, we know it is 0.1 molar. It's given. Volume, we know it 150. Mass, we don't know. But molar mass, sodium hydroxide, let's find the molar mass here. NaOH. N is sodium, O is oxygen, 1 is hydrogen. So sodium is 23, you will find from periodic table. 16 is oxygen plus 1 is hydrogen. It will be equal to 40, is it? So we'll write 40 here. Multiply by 1000. Divided by volume in milliliter, how much we have? 150. Now we need mass actually. Mass should be in grams always, okay? So what can we do? We cross multiply. So it means if I want to solve this here, it will be like this. 0.1 is equal to mass. It will be equal to 1000 mass. 1000 multiplied by m divided by 40 times 150. How much? The down one. It will be 6000, I think.
6.6.
This one.
No.
6000, I think.
6,000, yes.
Yeah, mass, because this is multiplication, so you should above you should multiply, down you should multiply. Okay, so now it is equal to 0.1 equal to 1000 times m divided by 6000. Now we need mass. It means 1000 m, if I can have different color, 1000 m will be equal to 6000 times 0.1. It will be equal to 600. Is it clear?
Yes.
Because 6000 times 0.1, it will become equal to 0 here. Now 1000 m means m will be equal to 600 divided by 1000, 0.6 gram. Clear or not? So we have two types of calculation. Now the question is, if the same question is there, mass is not asked, rather mass, we say moles. Moles of sodium hydroxide in this solution. Let's go for the other side. This is two-step, this is not multi-step. We have, what is the mass? If you remember, 0.1 was the molarity. And then volume was how much? 150 ml. And the material was sodium hydroxide. Okay. And then moles, we don't know. So you have the formula, molarity is equal to moles divided volume in liters, is it? This is the formula. This formula is same is like this: mass divided by molar mass multiplied by 1 divided by 1000 divided by volume in milliliter. This is the same. But here molarity is 0.1 Mass is moles, we don't know. And volume in liters, how much? 0.150. Because, or we can say, okay, forget about this one for a while. So we need moles. So moles is equal to molarity into volume in liters. Can I say like this? Cross multiplication. We cross multiply. N here, M here. So moles is equal to molarity multiplied by volume in liters. So molarity is 0.1. Volume in liter, but we have volume in milliliter. So what would I do? I will directly change into liter divided by 1000. I can say 150 divided by 1000. So it will be equal to 0.1 multiplied by 0.15. So it will be equal to how much? 0.015 moles. Now it will be moles. Now I need mass. We changed the process. Before I directly went to the mass. Now first I find the moles and then I'm going to the mass. Whenever you need mass, we have the mole formula. Moles
multiply
mass divided by molar mass. This is the formula. So if I need mass, this will be equal to moles, which is N, multiplied by molar mass. These formulas are really important in stoichiometry. So moles, how much we have moles? 0.015. Multiplied by molar mass, we already calculated for sodium oxide, it was 40. Can you calculate it?
0.6.
Let's go to the previous slide. Here. 0.6 and 0.6, because first here we did two steps. First find the moles and then went to the mass. In the previous one, we directly went to the mass because we didn't use the mole here. We directly changed the mole formula here. This is mole because we needed mass directly. So if you needed mass directly, you need mass directly, go for this formula. If you need moles, go for this formula. This is a very famous formula in your in a solution. This one. This formula is very useful formula. Now I will give you an example. Suppose you did the process. I think some students will have acid-base titration in the exam. Did you have an acid-base titration, some of you? Acid-base titration. Acid-base titration.
Yes,
An exam.
in the
In
final.
the final exam. In the final exam, first of all, you will go for titration and then find the molarity of HCl. Suppose the molarity is 0.095 molar. And then we use 10 ml of HCl. Okay, so then in the question after the experiment, it is written, find the moles of HCl. Moles of HCl. Now the student, they are confused. How to find the moles? You have the molarity, you have the volume. Why can't you use the find the moles? Use the formula. Molarity is equal to moles divided by volume in liters, or moles is equal to molarity multiplied by volume in liters. You have molarity 0.09 and the volume is 10 milliliter, but you change into liter, it will become equal to 0.01 liter. That's it. The moles will be 0.009.
Times 10 to the power minus 4.
Yeah. No, like this. How much? 0.0095, or you can say 9.5 into 10 to the power minus 3 moles. Is it okay? This is the straightforward question. Usually the student, they are confused of how to find the moles from molarity. You can find moles from molarity if the volume is given to you. If you know the volume.
10 to the power minus 4.
10 to the power, sorry, this is 0. Okay, you can say 10 to the power minus, if it is, should be like this, huh? It will be like this now. Okay. Clear? Do you have any question about the molarity, how to find molarity, how to find the moles from molarity, how to find mass from molarity, how, if the mass is given, how to find molarity? So these are the questions you should know about this, the formulas, okay? One formula is being used in all these equations. Only one formula. This is the formula.
I have a question not related to this topic.
No, let us finish this topic now. I don't want to discontinue this. You can wait. Let us finish this one, and then I will give you a chance later on. Let us finish this one. If it is related to this topic, ask the question. If it is not, then wait. Okay? We will finish this topic maybe in 20-25 minutes. Then after that, you can ask any question you want. Okay?
Yes.
Okay. Let's go for, now we go for dilution actually. Dilution. Dilution means we have a solution we call standard solution. Standard solution. Standard solution means if I take 2 grams of sodium hydroxide and then I dissolve in 250 ml of water, 250 ml of solution, what is the molarity? Can somebody tell me the same, use the same formula? Molarity is equal to mass, which is mass of sodium hydroxide divided by molar mass of sodium hydroxide, multiplied by 1000 divided by volume in milliliter. So I will use 2 grams divided by 40, which is the molar mass we already calculated, multiplied by 1000 divided by the milliliter is 250. Can you give me the molarity?
0.2.
0.2 molar. Yeah, 0.2 molar solution. Okay, so do I know the molarity of this solution? Yes, that's why this is called standard solution. If you know the concentration of a solution, it is called a standard solution. It is called a standard solution. Now I have beaker. Suppose I have this flask. Which flask is this? Volumetric flask. Okay, and it is written 250 ml. And then this is full with my solution, the one I prepared right now. It is like this. This is my solution. Okay, 250. This is my solution number 1. What is the molarity? I know it, 0.2 molar. Why? Because I made it. Now, what I do actually, I want to dilute this solution. I want to dilute it. What do you mean by dilute?
تخفيف. Make it more, less.
Lower. I'm going to the lower concentration. When I'm diluting it, what would I do? Suppose I will give you example, common example. We have 2 cups. This is 1 cup, and then and there's another cup. Suppose. So they are same cup. I went to the point of sale here in our canteen or in our cafeteria, and then I asked the guy, put 1 spoon of sugar in my tea. He made a tea, but accidentally he put 3 spoons of sugar because he didn't hear properly. When I tasted it, it was too sweet. So I asked him, what did you do, Miss? It's too sweet, I cannot even drink it. So now there are two ways, either to waste this, means this tea, to make another cup, or I can make something. What can I do? The other option.
Add more of water.
Water, yeah. Always I will dilute it. So I will take, this cup is full now. I cannot add more water in this cup. So what would I do? I will take a cup which is empty and then add some of them, maybe a little bit like this, 1/3 of the quantity, and then I will add water, the hot water with tea. Or we have tea without sugar, I will add it. So I'll make the volume like this. So this is called dilution. So what will be the effect? Now, because the sugar will be according to my standard, the sugar will be a little bit lesser now in my solution. So for dilution, you don't do the dilution right here because you don't have space here. Here, you don't have space. So what will you do? You will use the pipette. If you remember, this is a pipette. With pipette filler, this is a pipette filler, I think, if you know it. Pipette filler, okay? Use the pipette and pipette filler. Suppose this is 10 ml. You will take 10 ml, but you will take another flask. You want to find the flask now. The problem is with your volumetric flask. Volumetric flask, no, volumetric flask.
Okay, so
I did not find 250 ml. I found only 100 ml. That's good, no problem. So I will transfer from here. I will take out some solution 10 ml, transfer it here. How much? 10 ml. And then I have a wash bottle. We call it distilled water, water only. I will add water to make the volume up to, there's 100 here. And this solution is diluted or not? Of course it is diluted because I took 10 ml. Now we have calculation, come to the calculation. We have two solutions, number 1 and number 2. This solution number 2. What is the volume of solution number 2? Total volume.
100.
100. And what is the molarity of solution number 2?
Not
We don't
unknown.
Unknown. We will calculate it, don't worry. And what is the molarity of solution number 1, the standard solution, the one we have it?
0.2.
0.2, we call it M1. Huh? What is the volume of solution 1?
10 milli.
250.
Decide by yourself. It is a 10 or 250 ml. We have two volumes now. Yes. Did you decide 250 or 10?
250.
Okay. Why did not I write 250? Why? Because 250 is the volume and doesn't matter. Whenever we do dilution, the volume matters for us. It is the amount of volume I take out for dilution purposes, which is only 10 ml. I took 10 ml from here and diluted to 100 ml. Means I will add 90 ml of water, is it? 10 ml is here. I will add 90 ml of water, but I am not caring about the water, rather, I will care about the whole solution after dilution. Okay? So V2 is the volume of water you added plus the volume here for dilution. So 10 plus 90 will be equal to 100. This is my V2. But V1 is not the volume of this flask, this solution. V1 is the volume you take out for dilution. This is the important step here.
So teacher,
Yes, please.
the molarity in the pipette It is the same as the molarity for the 250 volumetric
Yeah,
flask.
of course. Why not? Because look at this. We take this solution. What is the molarity? We know it. The concentration does not change. If I take 10 ml, it will have the same concentration. It is like this. You have a teacup, and then you dissolve the sugar in it. The first sip, the middle sip, and the last sip, they will have the same taste, sugar taste. Why? Because it's dissolved completely. If you say, no, if I take one sip, it will be less sweeter. No. If you take one sip or two sip or three sip, unless you finish the whole cup, it will taste the same if it is completely dissolved. So it means if the taste is same, the molarity is same. If you take 10 ml, the molarity will be same. If you take 20 ml, still the molarity will be same. If you take 50 ml, still the molarity will be same. The molarity does not change. Okay. Now we have the formula. Let's go for the next. How to find M2? Because we know that solution number one, M1, V1. M1 is 0.2. V1 is 10 ml. M2 is how much? We don't know. And V2 is the volume total solution of the second one, the dilution. How much, which flask you take? It's 100 ml. Now we have the formula M1, V1 is equal to M2, V2. M1 is how much? 0.2. V1 is how much? 10. M2 is how much? We don't know. Write M2. V2 is how much? 100. So M2 will be equal to 0.2 times 10 divided by 100. It will be 0.02 molar. Clear?
Okay, clear, yes.
So this is the molarity of diluted solution. The molarity of our standard solution was 0.2 only. Now it is 0.02. All is dilution. In dilution, the molarity goes to lower, concentration, 0.02. Now the question, usually the student, what they do, they change into letters here. In dilution, no need to change into letters, because look at this. You have M2. M2 is like this. M1 multiplied by V1 divided by V2. This is in milliliter. This is also in milliliter. No need to change into letters here, because if you change into letters, still you will have the same answer. The answer will not be changed. So why would you spend your time to change into letters here?
Yes.
If a dilution is there, because V1 will be in milliliter, V2 will be in milliliter, no need to change here. Okay, this is 100 milliliter. I will take 0.1 liter. I will divide here 0.01 liter. If you do the same, the answer will be same. M1, 0.2. V1 is how much? 10 ml. You change into 0.01 liter. Okay. And V2 is 0.1. Still, you will get the same answer. So means no need to waste your time here in dilution to change into liters from milliliters. Keep milliliters there, because they will cancel out at the end here and here. You'll find only the moles per liter. Clear or not?
Yes.
Yes,
Okay, clear.
teacher, of the
Yes, please.
question, give me the molarity, but not give me the volume. Same type.
Why not? Where is the volume? 100 ml. We already decided to have the volume. It is 100 ml.
No.
Now,
but,
okay, I will twist our question. I will twist the question now, the same question. Let's go to the next slide. Oh, sorry. What is this? Where is my, yeah, here. Let's make, yes, please.
Can you write a question, a full question, like the
Yeah, I will write it. I'm going there. I'm going there. Wait a minute. I'm going there. Don't worry. Sorry. Let me insert some duplicate slide. Let me make some more empty slide. Okay, so let's go. Now we will make a question first, because these things were for understanding. Now we are going for the questions. Now we will not make something else. We will make a question. Let's see. We say that a solution of 0.2 molar is being diluted 10 ml, not a solution. 10 ml of a solution of a 0.2 molar solution. Okay, wait a minute. Let me erase everything. 10 ml of 0.2 molar solution is diluted to 100 ml of into 100 ml. Okay, find the molarity of diluted solution. Diluted solution. Okay, now this is a question. We have a solution. We take 10 ml. What is the molarity? 0.2 molar. This is our solution number 1. And we dilute it to 100 ml. This is solution number 2. Find the molarity of dilution. It means M2. This is V1. This is M1. And this is V2. And this is M2. Now you will use the same thing. M1 V1 is equal to M2 V2. M1 or M2 will be equal to how much? M1 times V1 divided by V2. So we have the same thing, 10 ml, sorry, 0.2 molar multiplied by 10 ml divided by 100 ml. It will be 0.02 molar. This is the question. Clear?
Yes.
Now we go to the other slide and then we will, mix it up. Now we say that 10 ml of an unknown solution, unknown concentration, solution concentration. Yeah, unknown molarity, yeah. Is diluted to 100 ml, and the molarity is or the concentration is 0.02 molar. Find the molarity of unknown. Molarity of unknown solution. Okay, now the question says we have two solutions. The first solution, the molarity is unknown. M1 is unknown. V1 is there, 10 ml. Okay, and M2 is given. V2, where is V2? Yeah, this one. V2 is given. So we use the same formula. M1 V1 is equal to M2 V2. M1 is how much? We don't know. So we will say M2 times V2 divided by V1 if we want to find M1. So M2 is how much? 0.02. And V2 is how much? 100 ml. And V1 is how much? 10 ml. Clear or not?
Teacher, this one easy because it is a matter of calculation.
Yeah, now we go to the next question, the same question. We will repeat this one so that we know different angles of this formula. Okay, we will change the question now. The next question says an unknown volume of 0.2 molar solution is diluted to 100 ml, dilute to 0.02 molar and 100 ml. Volume is 100 ml. So unknown volume, V1, we don't know. M1, it is given. This M2, this is V2. Now use the same formula. M1, V1 is equal to M2, V2. So now we need V1. Huh? So V1 will be equal to M2 times V2 divided by M1. So M2 is 0.02 and V2 is how much? 100 divided by M1 is how much? 0.2. Clear?
Yes,
Yes,
clear.
teacher.
So we have one question, we made 4 questions from it. V1, we can find. Yeah, means it doesn't matter. Okay. Now I will give you one more question and then we will leave. Yes, please. Okay. So now you have another question. 2 10 ml of 0.2 molar solution to 90 ml of water is added. What is the concentration of the new solution? What is the molarity of the diluted solution? Okay, it's a really bad writing, but I don't care about the writing. Okay, so now we have 10 ml solution 1, V1. M1 is this one, we know it. 90 ml of water is added. Oh, this is not, we are not talking about solution, we talk about water.
18 molarity.
This is our solvent. Means the molarity we will find, suppose M1, V1 is equal to M2, V2. M1 we know it is 0.2 molar is given. V1 is 10 ml. M2 we don't know, but V2 is how much is V2?
100.
If we have 10 ml solution 1 and then we add 90 ml of water, this will be your V2. If we talk about the water, then it means the volume you take, you add them together. Look at this. To 10 ml of solution, 0.2 molar solution, 90 ml of water is added or mixed. So it means 90 ml plus 10 ml V2 should be 100. So M2 is how much? Again the same. 0.2 multiplied by 10 divided by 100. 0.02 mole. Clear?
Yes, good.
I think this almost we finished. Means what I felt, maybe you have these kind of question, you may have difficulty. So I solved all these with different angles, from different angles, using the same dilution law. M1 V1 is equal to M2 V2. Any questions?
No question.
Yeah, one
Last
question. The one student he was asking some question about the other topic. This molarity topic is finished now. We are going to the pH and pOH, but before this, I want to listen to the student who was asking some question about other topic. If you have time, so I'll be here for maybe 30 minutes more. Yes, please.
Yes, teacher. It's about. I want to know how the question become for. If he gave me the nitrogen with 6 atoms that are separated.
How?
It is in the homework.
No, nitrogen with?
Nitrogen. Yeah, 6 atoms are separated and combined with carbon.
How 6 atoms are separated?
I mean, lone, not paired.
No, I write nitrogen in 2. Is it okay?
Nitrogen bounded with carbon and triple bond with oxygen.
Okay. Like this?
Yes, and 6 atoms are in the nitrogen.
6 atom in the nitrogen, how?
Yes, 2 dots
6
above
electrons.
it.
Yes.
Yes,
6
2 dots above it.
electrons. Like this.
Yes, exactly.
Like this. These
And
electrons,
2
these are
with
electrons, not
oxygen.
atoms, okay?
Okay.
Into proxy. So, what do you want now?
So that the screen is black. We can't see.
My screen is black?
Yes, I can't see anything. Okay, now it's become maybe bad internet.
Okay, yeah, please. Now, what is your question? What should I do? Formal charge or what?
How the question become in this? So what he's asking, like nitrogen, we apply the formula that's the number of a group minus the lone pair, I think, so, right, teacher?
Wait. I understand your question. Okay, we have 3 different types of structures here. Let's go for this one. This is out of topic. Actually, this I think the Levy structures, huh? So I will
Yes.
in 2 minutes or 3 minutes I will try to finish this one. But you will be a little bit sharp enough to catch me. Let's see.
Yeah, I'm good at this.
Yeah, formal charge. We know this formal charge. We have 3 structure for NCO like this. First is like this, NCO. Second is like this, NCO. Third is like this, NCO. Okay, so these are Levy structure actually. We will make it octet for this one. 2 plus 6, 8. 4 bonds here, 8, and then 1 means 2, 4. 2 bond is considered as 2 electron. Okay, so 4, 6, and 8. Here 2 bonds means 4 electron. We need 4 electron more. Okay, and here we have for carbon 4 plus 4, 8 is completed. For this oxygen we need 4 more electron to make it octet. Okay, and
So
for this
teacher,
nitrogen
maximum is
yeah,
8.
there should be 8, yeah, and the Levy structure you should make it 8, not for hydrogen, only for the carbon, oxygen, nitrogen, sulfur, chlorine you make it 8. For carbon it's okay. Here we need only 2 electrons. Now which of these is the best structure, huh? Best Levy structure? This will be your question. Hopefully you will not this kind of question in the exam, but this is good for you. Best Levy structure. Your friend will be say if it is not an exam, just leave it. Go for some other thing. Best Levy structure. Okay. So now formal charge. We have to find the formal charge for nitrogen, carbon, oxygen in this structure. For nitrogen, carbon, and oxygen for this structure. For nitrogen, carbon and oxygen for this structure. First of all, how many valence electron we have in nitrogen? You know, for valence electron, it's very easy. You go to the group number. Nitrogen is in group number 5A. It means it has 5 valence electron. Carbon is in group 4A. It means 4 electron. And oxygen is in group 6A, means 6 valence electron. Same. 5, 4, 6. 5, 4, and 6. And then minus, how many non-bonding electrons for nitrogen here in this structure? 2, I think.
2.
How many non-bonding electrons
0.
for carbon? No, 0. We will write 0 because we don't have any non-bonding electron. And for oxygen, we have how much? 6 in this structure. Go for the second structure here. For nitrogen, how many we have? 4. For carbon, 0. For oxygen, we have 4. And for the other structure, how many for nitrogen here? Now in this case, we have 6. And here is 0. And here is how much? 2. Now, next step is minus. How many bonds for nitrogen we have here? Bonds. 3. How many bonds
Why
for
teacher
carbon?
minus?
4.
We are minusing it. Because the formula is like this. If you remember the formula of the formal charge, the formal charge formula is like this. Formal charge, number of valence electron minus number of non-bonding electron minus number of, half of minus of number of bonding, half number of bonding electron. But half number of bonding electron means bonds, number of bonds. Okay, number of bonds. Because if you have 2 bonds, you will have 4 electrons. If you divide by 2, it will become 2 again. So that's why 2 bonds means 2. We will write 2 directly. Okay. Here for carbon, how many bonds we have? 4. We will write 4 here. For oxygen, how many bonds? Only 1. That's it. Here for nitrogen, how many non-bonding is being finished? How many bonds for nitrogen here? 2. How many for carbon here? 4. This is 0 actually. Okay.
And
How many for
teacher,
oxygen here bonds? 2. Okay, let me finish this.
okay.
Here we have 1. Here we have 4. Here we have 3. Okay, now minus it. 5 minus 2, 3. 3 minus 3, 0. 4 minus 4, 0. 6 minus 6, 0. 0 minus 1, minus 1. Now here for this one, nitrogen, 5 minus 4, 1. 1 minus 2, minus 1. 4 minus 4, 0. 6 minus 4, 2. 2 minus 2, 0. Here 5 minus 6, minus 1. Minus 1 minus 1, minus 2. Here 0. And here 6 minus 2, 4. 4 minus 3, 1. But we will write, because this is 1, we will write plus 1 here because it's plus 1. Now you ask your question.
I apply another formula, which is number of groups minus bracket number of electrons that are not paired plus the bonding number of bonds.
Yeah, this is the same thing. Usually the formula, the group is nothing. Group is nothing because it's all about electrons. But group give you information about electrons. That's why I told you the number of electrons here, valence electron, you find from the group number. Okay, number of valence electron, this actually equal to group number. Okay, group number A, which is A. Number of non-bonding electron means the one you see dots. How many dots are there? These are the number of non-bonding electrons. Okay.
Yes, clear. If you
now,
have
which
time
one is the best structure? Which one is the best structure? This is the best structure. This is
Why?
not the best. This is the worst structure we have. And this structure and this structure are okay, but this is more okay. Why? Because oxygen have negative charge, here nitrogen has negative charge. When you have oxygen and nitrogen, oxygen has more electronegativity, it is on the right side, so this will be okay more. But this is actually, we did not teach you, I think. This semester we did not teach you. Because if you look at the periodic table, nitrogen, oxygen, fluorine. If you have to choose, this is -1, this is -1. Which one is more preferable? Oxygen. If this is -1, suppose we have nitrogen and oxygen, fluorine, oxygen, which one? This is -1, this is -1. Which is preferable? This one, not this one. Why? Because they're in the same, same period, but to the right side. The right
Because
side
they want to be like noble gases, right?
Yeah,
If
it
it is
will means the
become
one which
close
is near
to-
to the noble gases, it will be negative, more negative, okay?
Oh,
So that's why we have this preferable structure. The top priority is this one. This is 1, 2, 3. Top priority, second priority, and third priority. That's it.
and is it the same to find the isotopes?
No, isotope is different thing. Isotope is different thing. It's completely different topic, not related to this one, okay? Now, the other students, the students, I will go to pH. You have time with you, or should we finish this one?
Yes, teacher, go, no problem.
Okay. So basically we finish molarity, and this Levy structure, I don't think so the formal chart will be in your syllabus. This is not in your syllabus for this semester. So if you did not learn it, no need to learn it right now. If you learned it, it's good for you. Okay, but I don't think so it will be in the exam because we removed it from the syllabus, from our syllabus, formal charges. Okay, for this semester. Now we go to pH. pH and pOH. pH and pOH, it's actually linked to molarity or molar concentration. We call molarity or molar concentration. Because we have different concentration unit, if you remember, percentage, ppm, and ppb, molarity actually a molar concentration. This is called molarity. Now, what is pH? We have acids and we have bases. Acid and bases. The acid, what is the definition of acids? All those solution, and this is a very common or basic definition of acid. All those solution, when you dissolve in water and they will give you H positive ion, we call hydrogen ion, they're called acids. Bases, all those solution when you dissolve in water, they give you OH negative ion, they're called bases. Understood? Acids, all those compounds, when you dissolve them in water, they produce H positive ion. All those compounds, when you dissolve them in water, they produce OH negative ion. They are bases. So how much hydrogen ion you have in the solution? Suppose you have HCl, you dissolve in water, it produces H, like H positive. How much hydrogen you have in your solution? You can find from pH. Means not the molarity. Suppose if I say HCl, we have 100 molecule, we dissolve in water, we get 100 H positive. This is 100 ions in solution, but we need the molar concentration here. Molarity 0.1 molar, 0.2 molar, 0.001 molar, 0.0001 molar, 0.05 molar, 1.5 molar, like this. We need all these in molarity, molar concentration. That's why how much hydrogen ion are present in your solution, we measure with pH. If you know the pH, we can find H positive concentration directly, very easy. Okay, if you find OH negative, we can find the pH as well. So pH and the molar concentration of H positive, OH negative, they are linked with each other. Let's go to the next slide. We have pH. How to find pH? We say pH is equal to minus logarithm which is to the base 10. Usually in your calculator you have like this as well. Whenever we go for the pH minus log, it will be the base will be 10 and hydrogen ion concentration. Hydrogen ion, we have, it is inside the square brackets, which is called molar concentration. This square bracket actually, we call it molar, mole per liter or molar. Okay, this is called molarity or mole per liter, square brackets. So it means pH is equal to minus log of H positive molar concentration. Now, if suppose somebody gave me H positive concentration is how much? 0.1 molar. So what is the pH? It's very easy. If you have calculator, you can find it. pH will be equal to minus log of, what is the hydrogen concentration? 0.1. It will be equal to 1. The pH is equal to 1. Now, if the pH is equal to 1, a solution with the pH of 1, it's highly acidic. We call this acidic. Why? Because we have a pH range here. pH, we have range. It starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. This is the range of pH. If any solution whose pH range is from 0 to 6, this is called acidic. And then any solution whose pH is more than 7 to 14, we call it basic. These are bases. The pH which is less than 7, we call them acidic or acids. The pH which is more than 7, we call them base. Now if you look at HCl, the pH was 1, it means it is here. So it is highly acidic. So the pH range, whatever 7, that is neutral in between. Yeah, neutral. Like water, the water pH is around 7. Like the Pepsi can, why we ask we advise, or the doctor advised the people don't drink Pepsi Cola or all these soft drinks in the morning without the breakfast, because these have acidic pH, maybe around 2.5 or 3. If you drink it in the morning without doing breakfast, before the breakfast, so it will increase the acidity level of your stomach, because your stomach is already 1 molar HCl. The pH is 1 or 1.2 like this, the stomach pH. And then you are adding more acid, so it will increase the acidity of your stomach and you will feel heartburn. Yes, please.
Which more strong acid, 6 or 2?
2.
2. Okay.
Yeah, if you talk about acid strong, the pH, look at this, it depends upon concentration. Suppose you have, this is 0, 1, 2, 3, 4, 5, 6. This is strong. And this is weak. Okay, if you have pH between 0 and 1, 0.5, it's more stronger. If you have 6.5, it's very weaker acid.
Can it be 0, teacher?
Yes, it can be 0. To some extent means it can be 0. It depends upon the concentration you have, because actually this is a numerical value. pH means minus log. If you take the minus log, okay, it could be 0 equal to 0 as well. It could be 0.1, but it's difficult to make it 0. It may be 0.001. It's very small, but it's not exactly 0. It may be 0.001 like this. Okay, it may be a little bit more than 0. It's less than 1, even less than 0.1. It may be very less. So we have this range. This range, why we have this range? Because of the water. Okay, you don't want to discuss it anymore. Let's go for some other calculations now. You have pH.
Teacher, just one question.
Yes.
if he gave me the POH and asked for H
Okay.
plus.
No, I don't want to talk about pH now because it's coming. pH is like this. pH is equal to minus log of H positive. What about pOH? pOH is the same, but you will change it OH like this. Minus log of OH negative concentration. But we don't measure it directly. We don't measure it directly. So how can we measure? We measure pOH from pH. pOH we don't measure directly, rather we measure from pH. First we find pH and then we find pOH. How? Because we have a formula which is pH plus pOH is equal to 14. This is the formula. If I find pH, pOH is very easy for me. Is it? Is it clear?
Yes, teacher.
Okay. Now before this, yes.
If I have BH, how can I transit to H?
Okay, this I'm coming towards this. First of all, so I will means 10 minutes more and then we will finish our today's session, inshallah. In 10 minutes, whatever I can give it to you, I will give you. So before this, actually, we have a formula. We say that H positive multiplied by OH negative concentration is equal to 1 into 10 to the power minus 14. Okay, mole per liter. This is the value. H positive times OH negative is equal to 1 into 10 to the power minus 14. This you must memorize this one. And then what is H positive? If you don't know H positive, but you know OH negative, so it's very easy. 1 into 10 to the power minus 14 divided by OH negative. Or if you know H positive, you don't know OH negative, you can use the same formula. 1 into 10 to the power minus 14 divided by H positive. Okay, this formula is very important. This is the formula, main formula. From main formula, we can find this one. Now, the question is, if I have H positive, suppose if I say H positive are equal to 0.1 molar, what is the pOH of this solution? So pOH solution you cannot find unless you find pH. So for pOH, you say pH plus pOH is equal to 14, and then pOH will be equal to 14 minus pH, but I need pH first. Where is the pH? Because H positive is there, it's very easy for me to find pH from here. So pH of this solution will be equal to minus log of H positive concentration. It means minus log of H positive is how much? 0.1. If you calculate it, it will become equal to 1. So my pH is 1. So what will be the pOH here?
13.
So pOH equal to 14 minus 1 is equal to 30. Okay. So that's why we have a table. Variable means normally we don't need to calculate it. Means we have to calculate, but there is a one table: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. This is pH. If we have 0 pH, what should be the pOH?
14.
Here. 14. If we have pH 1 equal to 1, and pH will be 13,
Yes.
12, 11, 10, 9, 8, oh, 7. Look at this. This will match. And then 6, 5, 4, 3, 2, 1, 0. Okay. So this all comes from this formula. Now we have another question.
Teacher,
We have, yes, please.
we have a special name for 7pH or OH.
This is called
Or,
neutral.
Okay, just neutral.
Yeah, neutral means H positive and is equal to OH negative, or pH is equal to pOH.
Okay.
This is neutral. Okay. So now we have another question. If we say that the pH is equal to 2 of a solution, how many OH negative we have here? There's a question now. pH is equal to 2, OH negative will be how much? Let's see. We have the formula pH plus pOH is equal to 14. I have the pH, I need pOH here. First I will find pOH, okay? So pOH will be equal to 14 minus pH, which is 2. So it will be equal to 12. That's very nice. So I have pOH found, it is equal to 12. I need OH negative now. So whenever you have a pH or pOH, we have a very useful formula. If you want to find H positive and you want to find OH negative from pH or pOH, 10 to the power minus pH and 10 to the power minus pOH. Is it okay? This is not exponent. This is 10 to the power. 10 to the power, okay? You will write 10 in calculator, and then in power you will use the function of power, and then minus like this, okay, in calculator. So H positive is how much we have pOH? 12. So now we want to OH negative. It's very easy now. OH negative will be equal to 10 to the power. What is pOH? Minus 12. That's it. 10 to the power minus 12. But sometime it will be like this. Suppose if we have the pH equal to 2.5 and the pOH will be how much? 11.5. And how much it should be? 11.5. How much it should be? 11.5. Now you have to calculate. The calculator will give you the answer. Don't write 10 to the power minus 11.5. Calculate it. So it will give you the answer. If you calculate, it will give you the answer. Okay. So if we have, suppose, if H positive, we give to the other question, we have pH equal to 1. How much H positive we should have? That's very easy. Use the same formula H positive because pH is given to you 10 to the power minus pH. 10 to the power, what is this? pH equal to minus 1. This means 0.1 molar. Clear?
Yes, teacher.
Any question related to pH and pOH?
No, teacher, I have a question about the exam. Can I ask?
You want to which question are in the exam or anything else?
Not about chemistry, about exam.
Yeah, please.
The will come multiple choice or I will write the number.
Multiple choice are very less. Maybe you will have 7 to 8 multiple choice question, and total question will be around 20 or 25 like this, from 20 to 25. Minimum 20, maximum 25 question, and then only 7 or 8 will be MCQ. The other will be matching, blanks, and blanks you should write it, and calculated formula, calculate. In calculation, you don't need to write the like suppose I say 0.1 molar, no need for molar, just write 0.1. The molar will be taken by the system itself.
without units.
Yeah, without units, you don't need units for. And calculated formula, no need the units. Because units, if you write units, it will make it wrong. So don't need to write the units, only the number.
Yes, thank you, teacher.
Okay. Any other question? We finished the pH and pOH.
Not related to this topic, teacher. I have a question.
Yes, please. Now you're open to ask any question because we finished what we wanted to finish.
If he gave me a structure, loose structure, how can I find the isotopes for it?
Isomers, not isotopes. Isotopes
Yes,
are
isomers,
different than
sorry.
isomers.
Yes.
In living structure, no need for the isomers. In isomers, you will be asked only in organic chemistry and hydrocarbons, not in living structures. Okay, in structure of hydrocarbon, suppose you have C4H10. How many possible structures are there? How many isomers are there? We call it isomers. Now it's very easy because you should know certain rules for this one. 4 carbon, suppose this is my question. I'm in exam right now. I'm a student. This is how many isomers are possible for C4H10? So now I'm confused. How can I find it? I don't know. So let's start it. I will do some I will write some structures and then I will try to find it out. How many carbon I have? 4. I will write like this: 1, 2, 3, and 4. Now for the next one, this is my main chain. I will not write 4, I will rather write 3. For the next one, I will not write 3, I will write only 2. For the next one, I will write only 1, like this. What I'm going to do here, in this structure, I write 4 like this, suppose. In this structure, when I write 3, it means I remove 1 carbon. I have to make 4 carbon here. And then I will make is a branch here, either here, or here, or here. Up or down, it doesn't matter. And then if I want to make it like this, 2 carbon, it means I have to remove 2 carbon from here and make is a branch here. Here, here, I can do it. If I make 1 carbon, it means I will make 3 carbon as a branch. So how can I make it 3 carbon? I will write 1 carbon here, 1 here, and 1 here, like this. But let's start it. The question is, can I do it all or possible or not? Let me go. Eraser, yeah. Okay, no. Let me erase all. No, I don't want to erase all. Okay, I will erase all. No problem. So let's see again. 1, 2, 3, 4. Now I want to make it 3 carbon. This is my straight chain. This was C4H10. This was my question. Now I want to make a branch here. Usually, if this is suppose this is a rope. Okay, and you want to cut a piece from here and then make it a branch. So you can make it a branch. Can you make a branch here?
Yes.
This one I cut this. No. You make a branch here? No. Why? Because the branch, if you make a branch, it should have 3 start or end point. This is a branch. 1, 2, 3. But if you make it here, suppose Still it has two endpoints, 1 and 2. 1 and 2. It means this is not a branch. Branch should have more than 2 starter endpoints. If you look at this carbon, one carbon is the start one is the end. This is the start, this is the end. Terminal, we call terminal carbon on any side. If you make a branch here, so this is the start, this is the end. You did not make any branch. If you want to make a branch here, suppose, still the same. This is the start, this is the end. You did not make a branch. This is not a branch, this is not a branch. The branch should always be in the middle, not on the terminal carbon. So it means these two structures, the one I made, these are not the structure actually. It's the same structure as above. So I want to delete this one. Delete it. So this is not my structure even. Okay, so I will write again. Let's write again. Okay, I will make 3. I will make a branch here. That's very nice. Now you have 3 terminal position. One is here, one is here, one is here. We made it 3 or not?
Yes.
Can I make it 4? Means let's try. I will try my best. So I will make it 2 like this, and then I will make a branch here and branch here. I cannot do it because if I made a branch here and here, so this will be like first structure. This is initial and this is final point like this. This is the same structure. This is not a different structure. Okay. You start from here, you end on here like this. So it means this is the same structure. If it is like this, I can make this, twist it to make it straight like this. This is a straight chain. This is not a branch one. The branch one should be like this, like this. If I want to make it straight, what will I do? Suppose there is a rope here, and this is actually the branch. Okay. If you want to make it straight, this branch, you will straight it like this. Okay, and this will come down, is it? If it come here, it will come down, and this will come here. You straightened it, but still the branch is there. Means you cannot remove the branch from here. So when it is in the middle, you cannot remove the branch. So this is a different structure. This is not a different structure. So there is no other possibility. I cannot make this branch to here because it will be the same structure like this. So there are only 2 possibilities in this structure. C4H10, only 2 possibility. So one is the straight chain, one is the one branch. Okay, now I will make it again a little bit easier for you. C4H10. So this is my first structure, and this is my second structure. That's it, 2. I cannot make it more. Now, hydrogen you can do by yourself because hydrogen 3, as we did before, 3, 2, 2 here. 3, 3, 3, and 1 here. Okay. Now we go for C5H10, 12, sorry. Okay, C5H12, 1, 2, 3, 4, 5. This is my first one. Now, 1, 2, 3, 4. And then 1, 2, 3. That's it. Not more than this. Okay. First, I will cut this carbon and put it here. Second, I will make another structure like this one. You will say, teacher, can we change its position? Yes. This carbon could be here as well. This is another structure. Okay. Can we make carbon here? No, not possible. Can we make carbon here? No, branch is not possible. Branch is possible in this carbon or in this carbon. 2 carbon. We put it here, we put it here. Okay, that's good. Now 1 branch is finished. Now we are going for the 2 branches. Okay, let's go for the 2 branches. So we will make a straight chain 3 carbon and 2 will be branches. We cannot make branch here, we cannot make branch here. So only one possibility, both carbons should be on this carbon. That's the possibility. But we have 4 structure now. 1, 2, 3, 4. But if you look at this structure, wait a minute. Look at this structure. This is the same as this structure, is it? You just move it 180 degree, not vertically, it's horizontally, means you bring this side here to this side and this side to this side. What will happen? It will look like the same structure as above. So it means this is not a different structure. This is the same structure. So we have three possibilities. Okay, now one is this one in 5 carbon, one is this one with 4 carbon, 1 carbon is here, and the third one, which is the last one, it is like this. So we have 3 isomers possible. Can I make it more isomer? No, it is not possible. We cannot make any branch. This is the last one. Now I will give it naming, and then that will be the end of session. Just give me a name. I will try to name these compounds, different compounds. Okay, for C5, 1, 2, 3, 4, 5. Okay, so we call it, this is pentane. Why? Because it's a straight chain alkane. CH2, CH2, CH2. 5 carbon pent. And because it's alkane, it should be pentane. Now we make a structure, if you remember. CH2, CH. We made one as a branch. CH3 here. Okay. This is like this. So what is the name of this one? Select the longest chain of carbon, straight one. Count them. This is 4. 4 means they are butane. 4 carbon alkane is butane. And then count numbering. 1, 2, 3, 4. You cannot count from this side because the branch comes near here. So it should be 2. What is the group name? The branch is methyl. So the name is 2-methyl butane. That's good. Now we tried the next structure like this, and then we finish it because we say that it's not a different structure, it's the same structure.
Why, teacher, we didn't say dimethyl?
Okay. Wait a minute. This is the structure. If you remember, we put this CH3 here to this carbon, and then we say this is the same structure. So that's why we write only one of them, not both of them. Look at the reason now. We have this one. How many carbon we have? 4. It means this is butane. We have methyl group, 1 methyl group, so it should be methyl as well. But what is the position? What is the position of this methyl group?
It would be 2.
2. We start counting from this side. 1, 2, 3, 4. This is same or different? 2-methyl butane, 2-methyl butane. Same. It means this is not an isomer. If your name becomes same, it means this is not an isomer. This is the one. This one and this one, they are same. So why should we write 2 times? Only write it 1 time. This is the same isomer. This is not a different isomer. Different isomers should have a different name. If they have the same name, it means they are not different isomers. So that's why we go for the last one. Look at this. This one. So we have this straight chain now. We didn't write the hydrogen. So how many carbon we have? 3. That should be propane. But this should be methyl group. Suppose this is methyl group. This is H3. These are not methyl. This is your main chain. So these are the branches. So what are the position of branches here now? One, 2, 3, 2. But there, how many methyls we have total? 2 methyls, 2 branches. So when you have 2 branches, you should write methyl. Methyl before propane, you should write methyl. But there are 2 methyl, you should not write 2 methyl or 8 methyl. You should write dimethyl. For branches, you should write di, not 8. Dimethyl. But what is the position of both methyls? 2 position. 2 for 1 methyl, comma, 2 for another methyl. So we should write 2,2-dimethyl propane. Clear? Is it okay? Yes or no? Is it okay or not?